right, so now we're looking at unique tangents. So when x is -1 for this graph, that assuming we're counting by ones, that's going to be over here. If I think about the tangent at, -1, well, looking at coming from the left, my tangent would look like this. But if I was coming from the right, my tangent is going to look like this. So that's not a unique tangent. Similarly, at 3, let's make that actually on the line. At 3, we would have our tangent here or here, depending on whether we were looking at coming from the left or coming from the right. Remember earlier we defined this situation to be that the graph is not continuous at that point, because my limit as x goes to -1 from the left of the function is not equal to the limit as x goes to -1 from the right. So these are discontinuous, and I do not have unique tangents. If I graph the absolute value of x, well, maybe you remember, I hope, what that graph looks like. Let's try to put in a straight line. Let's try to put in a vertically straight line. All right, so if I graph absolute value of x, well, that's going to look like this. Let's actually make it go through there. My boxes do not really appear to be square. Fine. And now if I try to draw my tangent at x equals 0, again, this function is not continuous at x equals 0. So there are no unique tangents at those points. Every other point, there are unique tangents. So if the function is not continuous, we do not have a unique tangent.